This lesson is on identifying quadratic functions and determining whether they have minimum or maximum points, and then graphing a quadratic function and giving its domain and range. The function y equals x squared is shown in the graph. Notice that the graph is not linear, not a straight line. This function is a quadratic function. A quadratic function is any function that can be written in the standard form y equals ax squared plus bx plus c, where a, b, and c are real numbers and a cannot equal 0, or else we don't have the squared term, which is what makes it a quadratic. The function y equals x squared can be written as y equals 1 times x squared plus 0x plus 0, where a equals 1, b equals 0, and c equals 0. In Lesson 5.1, you identified linear functions by finding that a constant change in x corresponded to a constant change in y. The differences between y values for a constant change in the x values are called first differences. So the first differences in the x values, plus 1 plus 1 plus 1, constant change in x, and the first differences in the y values, plus 1 plus 3 plus 5 plus 7. The second differences are the differences between the first difference numbers. So for this quadratic, it's plus 2 plus 2 plus 2. Notice that the quadratic function y equals x squared does not have constant first differences. It has constant second differences. This is true for all quadratic functions. Tell whether the function is quadratic, explain. So they have a table of x values and y values. First, you check for a constant change in x. Then you find the first differences, which is plus 7 plus 1 plus 1 plus 7. And then you find the second differences. This function is not quadratic because the second differences are not constant. Be sure there's a constant change in x values before you try to find first or second differences. Tell whether the function is quadratic, explain. Y equals 7x plus 3. Since you're given an equation, you're going to use y equals ax squared plus bx plus c. So you need to rearrange it to see if it can fit into that format. This is not a quadratic function because the value of a is 0. There is no x squared term. Tell whether the function is quadratic, explain. Y minus 10x squared equals 9. So since it's an equation again, we're going to try to write it in the form of y equals ax squared plus bx plus c. So we need to solve for y by adding 10x squared to both sides. And that gives us y equals 10x squared plus 9. This is a quadratic function because it can be written in the form y equals ax squared plus bx plus c, where a is 10, b is 0, and c is 9. In a quadratic function, only a cannot equal 0. It's okay for the values of b and c to be 0. Tell whether the function is quadratic, explain. They give you a table and a list of ordered pairs. They've put them into the table for you. So you need to check for a constant change in x, and then take your first differences, find second differences, and see if those are constant. Then you can check back for your answer. So there is a constant change in of x plus 1 plus 1 plus 1. The first differences, negative 3, negative 1, 1, 3. And the second differences are 2, 2, and 2. This is a quadratic function because the second differences are constant. Tell whether the function is quadratic, explain. Y plus x equals 2x squared. So you can try this and then check back for your answer. So you're going to try to write the function in the form y equals ax squared plus bx plus c because it was a equation they gave you. And so you're going to solve for y by subtracting x from both sides, and that gives you y equals 2x squared minus x. So this is a quadratic function because it can be written in the form y equals ax squared plus bx plus c, where a equals 2, b equals negative 1, and c equals 0. The graph of a quadratic function is a curve called a parabola. To graph a quadratic function, generate enough ordered pairs to see the shape of the parabola. Then connect the points with a smooth curve. Use a table of values to graph the quadratic function y equals 1/3 x squared. Make a table of values, choose values of x, and use them to find values of y. So they've chosen -2, -1, 0, 1, and 2. These are good numbers to choose because they will keep your graph small and centered around the origin. When you plug in the values to the equation, you write what you get for y in the second column. So for y, we got 4/3, 1/3, 0, 1/3, and 4/3. Now you graph the points and connect them with a smooth curve. Use a table of values to graph the quadratic function y equals -4x squared. So again, you make a table of values and you choose values for x and use them to find values of y. -2, -1, 0, 1, 2, you plug each number into the equation and solve for what y is. So -16, -4, 0, -4, -16. If you notice, the numbers will start repeating themselves, which shows you that you've crossed over to the other side of the curve of the parabola. Now you graph the points and then connect the points with a smooth curve. Use a table of values to graph each quadratic function, y equals x squared plus 2. This one's for you to try, so you can create a table. They're going to choose the points -2, -1, 0, 1, 2 because they're easiest. If you choose other points, that's fine. Just know that these are the ones that will have the answers when you check back. So once you plug in those values for x and solve for y, you should have gotten 6, 3, 2, 3, 6. Once you notice that the numbers are repeating, you know that you've crossed over to the other side of the curve of the parabola. Then you graph the points and connect them with a smooth curve, and the graph should look like this. Use a table of values to graph the quadratic function y equals -3x squared plus 1. Again, they chose -2, -1, 0, 1, 2 to plug in for x. If you choose other values, just know these will be the ones that will show up on the graph for the answer on the slideshow. So once you plug them in for x and solve for y, you get -11, -2, 1, -2, and -11. Notice again, the values are starting to repeat themselves, which shows you that you've gone to the other side of the curve of the parabola. Then you graph the points and connect them with a smooth curve, so your graph should have looked something like this. As shown in the graphs in examples 2a and 2b, some parabolas open upward and some open downward. Notice that the only difference between the two equations is the value of a. When a quadratic function is written in the form of y equals ax squared plus bx plus c, the value of a determines the direction a parabola opens. A parabola opens upward when a is greater than 0. That means the number is a positive number. Think of it this way. A person who's positive smiles, so your parabola will be smiling or opening upward. A parabola opens downward when a is less than 0, or a negative number. So a negative person frowns, so your parabola will frown and open downward. Tell whether the graph of the quadratic function opens upward or downward. Explain. Y minus 1/3 x squared equals x minus 3. First, you need to write the function in the form y equals ax squared plus bx plus c so that you can tell what your a value will be, positive or negative. You're going to solve for y by adding 1/3 x squared to both sides. That will give you y equals 1/3 x squared plus x minus 3. 1/3 is the value of a, and since a is greater than 0 or a positive number, the parabola will smile or open upward. Tell whether the graph of the quadratic function opens upward or downward. Explain. Y equals 5x minus 3x squared. So you need to write the function in the form y equals ax squared plus bx plus c so that we can identify if the a value is positive or negative. When you rearrange the order, you would write it as y equals negative 3x squared plus 5x. So a is equal to negative 3, and that's a negative number or less than 0, so the parabola will frown or open downward. Tell whether the graph of the quadratic function opens upward or downward. Explain. Function of x, or that's another way of writing y, equals negative 4x squared minus x plus 1. So this one's for you to try, looking at the value of a and determining if it opens upward or downward, and then you can check back for your answer. So a is equal to negative 4, which is a negative number, or less than 0, so the parabola opens downward or frowns. Tell whether the graph of the quadratic function opens upward or downward. Explain. Y minus 5x squared equals 2x minus 6. So you can try this one on your own and then check back for your answer. You're going to write the function in the form y equals ax squared plus bx plus c by solving for y. you're going to add 5x squared to both sides. That will give you the equation y equals 5x squared plus 2x minus 6. So your value of a is positive 5, meaning it's greater than 0, so the parabola opens upward or smiles because it's positive. The highest or lowest point on a parabola is the vertex. If a parabola opens upward, the vertex is the lowest point. If the parabola opens downward, the vertex is the highest point. So if a is greater than 0, or a positive number, the parabola smiles, or opens upward. And the y value of the vertex is the minimum value of the function. So for example, if we had y equals x squared plus 6x plus 9, the parabola is smiling, and the vertex is minimum, it's at the bottom. The y value of that point is the minimum value. So for this one, the vertex is negative 3, 0, and so the minimum would be equal to 0. If a is less than 0, or negative, the parabola opens downward, and the y value of the vertex is the maximum point for the function. So for y equals negative x squared plus 6x minus 4, it's a negative value for a, so the parabola is frowning or opening downward, which makes the vertex the maximum point at the very, very top. The vertex for this one is 3, 5, so the y value, which is 5, would be the maximum value for the parabola. Identify the vertex of each parabola, then give the minimum or maximum value of the function. So for a, the vertex is negative 3, 2. It's at the bottom because the parabola is smiling, so it's a minimum point, and it's equal to the y value of the minimum point, which would be 2. For b, the parabola is opening downward or frowning, so the vertex is going to be the maximum point at the very top. This vertex is 2, 5, so the maximum is 5, the y value of the vertex. Identify the vertex of each parabola, then give the minimum or maximum value of the function. So you can try a and b on your own and then check back for your answer. For a, the parabola is opening downward or frowning, so it's going to be a maximum vertex. The vertex is equal to negative 2, 5, and the y value of the vertex is 5, so it's a maximum of 5. For b, the parabola opens upward or smiles, so the vertex is a minimum. The vertex is 3, negative 1, so the minimum is equal to the y value, which is negative 1. Unless a specific domain is given, that's the x value range, you may assume that the domain of a quadratic function is all real numbers. You can find the range of a quadratic function by looking at its graph. So for this one, y equals x squared minus 4x plus 5, the range begins at the minimum value of the function. So if you look, the vertex is 2, 1, which means that the minimum value is 1, the y value of the vertex. All y values of the function are greater than or equal to 1. So you would write the range as y is greater than or equal to 1. Find the domain and range. Step 1. The graph opens downward, so you need to identify the maximum point. The vertex is negative 5, negative 3, so the maximum value for y is negative 3. Step 2, you find the domain and range. The domain is not stated any differently, so you can assume it's all real numbers. The range then is any numbers less than or equal to negative 3, which was the maximum point. Here's one for you to try on your own. Find the domain and range. Step 1, the graph opens upward, so you're going to identify the minimum point. The vertex is negative 2, negative 4, so the minimum is negative 4. Step 2 is to find the domain and range. There was no domain stated, so we assume it's all real numbers. The range then would be any values for y that are greater than or equal to negative 4. Here's another one for you to try. Find the domain and range. Step 1, the graph opens downward, so you need to identify the maximum point. The vertex is at 2, 3, so the maximum value is 3. Step 2, find the domain and range. So the domain, since not stated otherwise, is all real numbers, and the range then is less than or equal to positive 3.